In section 3.2 for statistics, measures of variation, we've already talked about variance and standard deviation for samples, for populations, for group data. Now we're going to talk a little different about the coefficient of variation. So the coefficient of variation allows you to compare standard deviations for samples that do not have the same units of measurement. So it kind of standardizes things for us a little bit. We abbreviate coefficient of variation as C-var. And if you notice, both of these have pretty much the same formula. So S, or sigma, which is your standard deviation, one for sample, one for population, but it's still standard deviation. And then this was a typo, it's supposed to be X bar, and mu, which are both mean. So standard deviation over the mean times 100. Okay? So if you look, this is a really good example of what it means when we said they don't have the same units of measure. Sales of automobiles. The mean number of sales of cars over a 3-month period is 87, and the standard deviation is 5. The mean number of commissions is 52.25, and the standard deviation is 773. And you want to compare the variations of the two. Obviously, these are not the same thing. The number of sales versus the commissions are very different. So C-var, and I'm going to put sales over here, equals standard deviation over the mean times 100. And then we have commission, C-var, would be 773 over 52.25 times 100. So we end up with, sorry, I wasn't paying attention to where I was at. And you guys see me do this a lot, write the little approximately equal to. So the C-var for sales is 5.7%. The C-var for commissions is 14.8%. So the commissions are more variable. They have more variation or distance from the mean of their data. Looking at example 324, the mean speed for the 5 fastest wooden roller coasters is 69.16 miles per hour, and the variance is 2.76. The mean for the 5 tallest roller coasters is 177.8 feet. Variance is 157.70. Compare the variation of the two. So when you're comparing variation, that's where C-var comes in. What you do need to remember here is that they gave me variance instead of standard deviation. So let's say for speed first, 69.16 and 2.76. 2.76 under the square root divided by 69.16 times 100 is approximately 2.4%. And then for the height, C-var is the square root of 157.70 divided by 177.80 times 100, which is approximately 7.1%. So in this case, again, the heights are more variable. Right, the heights are more variable. The computer or the book for some reason had that written backwards. Next, we're going to talk quickly about the range rule of thumb. So sometimes we have some issues with trying to figure out our standard deviation. We don't have enough information. The range rule of thumb says that you can find a rough estimate of standard deviation by doing your range divided by 4. I mean, that's all it is. So if they ask you to do the range rule of thumb for standard deviation, you find your range and you divide by 4. It's that simple, guys. All right, that's it for this video. Next will be on Chebyshev's theorem.